In algebra, we are usually interested in solving inequalities, determining when two things are equal. But we can also discuss inequalities, determining when something is greater than something else or less than something else. So, for example, we can say this, that A is less than B. And sometimes this is just true. 2 is less than 5. But other times, if there's a variable, it can be true or it can be false. X minus 3 could be less than 5, or it could be greater than 5, depending on what value the variable x takes on. In general, solving inequalities is difficult. It's not something we want to spend a lot of time on, and we'll only look at a few rather limited examples. Let's start with the good news. You can add or subtract the same thing from both sides of an inequality. So we're used to doing this when we're working with inequalities. If we had x minus 3 equals 5, the way we'd solve that would be to add 3 to both sides of the equality. We're now saying that if we have an inequality, x minus 3 is less than 5, we can add 3 to both sides of that inequality. X is less than 8, which we could represent using interval notation like so. That's the good news. The bad news comes when we want to divide or multiply both sides of an inequality by something. And the reason this is bad news is that it breaks into 2 cases. Case 1. We can multiply or divide both sides of an inequality by a positive number. So let's say you have 2x minus 3 is less than 4. Maybe less than or equal to, just for variety. We can solve this inequality using this rule and the rule we just saw for addition and subtraction. We can add 3 to both sides. 2x is less than or equal to 7. And then because 2 is positive, we can divide both sides by 2. X is less than or equal to 7/2, expressed as an inequality like that. I mean, expressed as an interval like that. So that's fine. Case 2 looks almost like case 1, but there's a difference. If we multiply or divide both sides of an inequality by a negative number, we can do that, but it flips the direction of the inequality. What on earth do we mean by that? Now, let's say we have negative 3x is less than 9. And we decide we're going to divide both sides of this inequality by a negative 3. When we do that, it takes this inequality and it flips it so that it's now pointing in the opposite direction. Here, the left is less than the right. Here, the left is greater than the right. X is greater than negative 3. expressed as an interval like that. So I said that dealing with inequalities is difficult. What makes it difficult? I mean, this is a bit of a nuisance because you have to keep track of whether numbers are positive and negative, and you have different rules for them. But it doesn't seem like it's the end of the world. Well, suppose you have an inequality that looks like this. 1 divided by x minus 2 is less than or equal to 7. Probably the first step we have to perform here is to multiply both sides by x minus 2. We need x minus 2 to not be in the denominator of a fraction. And now, what inequality am I supposed to write here? Did we flip the inequality or didn't we? If x minus 2 is positive, this is less than or equal to. If x minus 2 is negative, this flips and becomes greater than or equal to. But x is a variable. X minus 2 can be positive, or x minus 2 can be negative. I mean, x could be anything. Maybe x equals 5. Then x minus 2 is positive, and we don't flip the inequality. But then again, maybe x is negative 1. Then x minus 2 is negative, and we do flip the inequality. So there's no way to know what to write here. And it's because of that that solving these inequalities is harder than solving inequalities. We'll only be looking at a few relatively simple examples.